Welcome back to Cricket Aviation. My name is Jim Payne, and I'd like to apologize. I tried to get videos out quicker. I thought that I was going to be able to go through the flight controls and actually get one video out at a time, but as I started doing work on the airplane here, I ended up starting with the rudder pedal system and finishing with the rudder pedal system. So I wasn't able to get the rudder pedal system done, get a video out, do the elevator controls, get a video out, and so forth. So I've been able to do a lot of work, and I've got probably 5 or 6 videos that I can have coming out pretty quickly. So what I'm going to do is in the next 2 videos, so this one and the next video are actually going to be a 2-part series on the rudder pedal controls. The first video, which is going to be this video, is going to kind of cover the rudder pedals, the rudder pedal tray, and then the second video is going to kind of focus on all of the cabling all the way back to the rudder itself. Now, just to kind of get you guys up to date, since I haven't done a video in a little while, I've got a lot done, not only with the flight controls themselves, which are now complete. So rudder system, elevator system, the aileron controls are done up to the point of the final control rods that connect to the to the ailerons themselves. So that's all done. I do have the nose gear final installation done, so the spring system is all done. I've actually riveted the top of frame 2 in, and the upper supports for the forward fuselage is done. I've also been working on throttle controls. I don't know if you can see it in the video here. This will be in one of the videos also, but I've got the throttle controls done, the ignition switch is done, that I'm going to use for the turboprops on the airplane. And one of the things I did spend some time on was this here, which is the Arduino throttle controls that I created for the turboprops, because I have to have basically what is potentiometers convert a servo signal to the ECU that's used by the KingTech turboprop. So again, this is going to be all in another video also. I've been working on the brake system a little bit. I've got the brake the brake handle installed. I'm going to actually work on installing and finishing the brakes. The seat tube is actually installed in the back here, so I have sat in this airplane quite a bit now. And now that I have the rudder pedals done, the rudder pedal tray done, and the seat so that I can sit in the airplane, I've been in and out of it a bunch of times, and I gotta say, there's some things we need to talk about. So I've always said I'm 5'8". Now, I've always been like 5'8 1/4". Reality of it is, I measured myself recently, and I'm actually about 5'8 3/4", so almost 5'9". My shoe size is 9.5". So I'm not a big person. I'm very average as far as an adult male goes. But sitting in this airplane, actually, I was quite surprised at how little room there actually is. Now, we all know this is almost like the world's smallest airplane. It's the world's smallest twin-engine airplane, but it's nearly the world's smallest airplane. I just thought there was going to be a little bit more room in this airplane than there actually is, and I think it's very important to talk about that, because if you're thinking of building this airplane and you're 5'10", you really need to take a consideration of your size, your foot size, and everything else, especially now that I've gotten into the rudder pedals. So I've got the rudder system completely done. I ended up having to move the rudder pedal tray all the way forward and actually install it so that I'm 1 notch back from the stops. And again, that's at under 5'9". That was a surprise to me. In fact, I had the whole rudder pedal system done, and I realized I had to go back and drill more holes to move the tray further forward than what I thought it would ever need to be. So again, that was a surprise to me, because again, you can basically do 1 position forward of where I have it right now, and you're at full stop. And again, I'm at 5'9". I'm not 6'1", I'm not 6'2". So again, just trying to put this into perspective for other builders who are thinking of building this airplane. Again, we know it's small. I just didn't know it was quite this small. I guess I was a little bit surprised. The other big thing that surprised me is the feet room. And I even had John, who's working with me on some of the build stuff here. I had him contact another builder who had finished and actually flown a CriCri before, to ask him some questions, because I was under the assumption that your shoe and the heel of your foot would sit on top of the rudder pedal tray, and that you would actuate the rudders back and forth again, with your heel on the rudder pedal tray. in reality, it doesn't seem to work that way, because if you put your foot on the rudder pedal tray and you push one foot forward, it moves the other foot back. But you cannot keep your heel on the tray, or at least I can't. Maybe my ankles aren't flexible enough, I don't know. But as my opposite foot comes backwards from the rudder pedal pushing it back, my foot has to come off of the rudder pedal tray. And the other thing I found is that my shoe actually does not fit in the airplane on the rudder pedal tray without the tips of my toes hitting the skin on the top of the forward fuselage. Not only that, my foot is like almost binding between the rudder pedal itself, the edge of it, where your let's say the right side of your foot's supposed to go, and the left side of my foot, or the inside of my feet, where the center support is for the upper fuselage. So I'm going to show you that in a second, just so you can see what I'm talking about. But again, all of this kind of surprised me. And then I'm also working on, let me show you here, you see here, I'm working on a new fuel tank. Now again, this became an issue too, because I had to put this in the airplane, and I had to sit in the airplane and make sure that my legs actually fit down the cutouts that were made in here, and see how I fit in the airplane with the fuel tank in. Now, we're going to go into this at another time, but just to bring you up to speed, if you saw my Instagram post, you saw a tank that John had sent me that was a complete fiberglass tank that was supposed to fit in the airplane. I ended up with some fit problems that we're going to talk about throughout the rudder pedal installation also, where once I actually got that tank installed with all of the flight controls in, it hit everywhere. I ended up having it hit the aileron cross tube, I ended up having it hit the steering control cables. It didn't fit well between frame 2 and 3. In fact, it was, there has to be a cutout, as you can see in the video, similar to this on the bottom, where it's supposed to fit between frame 2 and frame 3, and that seemed to be off enough that the front of the tank was hitting where it shouldn't and the back of the tank was hitting where it shouldn't. So again, what I'm trying to do now is actually mold a new fuel tank that fits exactly in this airplane. And if I'm to be producing kits and parts for it, the assumption is that if you bought that fuel tank, it should fit in any airplane. Now, I don't know why that other fuel tank didn't fit as well as it does. It came from another CriCri, or I should say another Cricket, which, again, frame 2 and frame 3 aren't supposed to have been modified in those configurations. So I don't know if it was a molding issue that we ran into where things just got a little bit off, but the fact is it didn't work, so we're going to create a new one. So again, I've been working on the fuel tank. I'm also working, and this is really preliminary because I've just had a few conversations now with a company to make the canopies, because that's the big thing I got to get a start on now so that I have something done for next spring, when I'm hoping to have this airplane done. So again, let me grab the camera, let me bring you over here. I just want to show you before we actually get into the video what I'm talking about with the foot room and the position of your foot within the airplane, because once I had the fuel tank in here and I sat in here, I realized another thing. I thought that these cutouts in the fuel tank, they go down like this, which are supposed to be for your legs. I thought your legs actually rested on the fuel tank. Now, maybe if you're actually short enough, they would, but even at my height, at 5'9", just under 5'9", my legs don't even touch the tank. I mean, they touch the tank on the side here when I'm actuating the rudder pedals. And the base, back of my thigh might actually rub or touch on the fuel tank itself. But you find out once you sit in the airplane, you have to move your legs back and forth to actuate the rudder pedals, and your legs are actually sitting above the fuel tank and moving back and forth. Now, it's not uncomfortable at all. In fact, the seat in this airplane is, I can't even understand it because it's all squared angles. It's actually very, very comfortable. But again, it was another surprise to me. And of course, once you sit in the seat, you realize that when you push your leg forward to push the rudder pedal and your other leg comes back, you can only push your leg forward as far as the seat angle will allow you to before you start digging into the back of your thigh. And you actually can't push any farther forward because, again, your legs have to bend at your hips. You don't really have the ability to just extend your legs all the way straight. So that became another factor of where the position of the rudder pedal tray was within the front of the fuselage. So again, there was a lot of surprises to me when I started getting into this that I wasn't expecting. So let me grab the camera and let's get into things a little bit more detailed here. Okay, so I just took one of my shoes. Now this is likely not a shoe I would use when flying, but I'm using it just as an example because this is a 9.5 size men's shoe. And I have it sitting on top of the rudder pedal tray where I thought my heel would go, and then I have it sitting here in against the rudder pedal. Now, one of the things you'll notice here is I have this little metal part that sticks out, and it's part of the bracket that attaches to these springs that hold the rudder pedal in the right position. I actually have to bend that back because what you'll notice here is with my shoe in this spot, it's pretty much hitting right here. In fact, I ran into a bunch of problems where I'd actuate the rudder pedal and my foot would be rubbing up against this area here. But also, you'll notice that if I would have put the skin over the top, my shoe would clear the top skin in this position by about, I don't know, a 1/16 of an inch. In fact, again, when I found out I was trying to, actuate the rudder pedals, I found out my shoe was hitting here and binding, my shoe was hitting here, and the tips of my toes were hitting the top of the fuselage. Now, the other issue here is I have those cutouts in the top. I was going to put nut plates on the bottom of those and, countersink the hulls and everything. My shoes would be catching on those nut plates and the screws that are coming down into the, access panels that I created all the time. So that totally took me by surprise because, again, I don't have big feet. 9.5 is not a big foot for a man. I don't have size 12 feet, so I wasn't expecting it. But then when I found out that when you actuate this rudder pedal forward, it takes this pedal over here and pushes it back. Well, your heel ends up coming back like this, and it becomes very uncomfortable because not only are you now hitting the top of the skin, your foot's catching on the back of the rudder pedal tray, which has a lip on it, and it just feels totally uncomfortable, like you just can't figure out exactly where your feet should go. So it actually feels better when you actually have your foot rested back here on the pedal rail that's behind the rudder pedal tray and actuate the rudder pedals as necessary and just kind of freely have your legs up in the air, and that's actually quite comfortable. The problem is it's weird to balance your foot on the back of this pedal rail and not have it on the bottom of the fuselage, which again feels weird. So now you're catching your feet all over on this thing trying to figure out where to keep your feet, which again is weird. And then I don't have the fuel tank in here, but you notice that the fuel tank has that large center section that comes across here. Well, then your feet start hitting the back of that in this area. So again, the fit of your feet in this whole area became a very odd thing for me to understand how it's supposed to work. And if there are any other CriCri builders who have built this airplane, flown this airplane, sat in it, and actually had any of these issues with your feet, I'd sure like to hear from you in the comments to find out, is this normal? I mean, I really almost feel like I should be putting some kind of support or plate or something across behind the pedal rail or behind the pedal tray to rest my feet on, because again, this doesn't seem to work. Not only does it not work, but it seems to get your feet too high, and again, your feet get stuck in here. So that was very strange. And you can see how far up my foot is, and this is with the rudder pedal not even actuated, and your legs are coming, up here above the seat and down here. And this is where you can see where the seat is. It's got this nice angle. It's very comfortable. But again, you can only push your legs so far forward until you hit this. You have to lift your leg up a little bit, push it forward. But once your butt and your thighs hit this, you don't have any more ability to push the pedals forward anymore. And you can see the angle down there. My foot is almost upright, and there's not much room to bend your foot back any further than that. Now, let's talk about this. There are some adjustments to the rudder pedals because I can take both these pedals and move them further forward by lengthening the cables on both sides evenly and then changing the straps here so that they're a little bit shorter. I can angle the entire pedals forward, and maybe that would help, but again, I don't think it's enough to make it so that your opposite foot that you're pushing on isn't coming back at an angle that your ankle doesn't want to go to, or at least mine sure doesn't. Not at 50 years old. So again, a lot of surprises here to me when I sat in it. Now these are set right now at the correct, I think it's 15 degrees angled forward is where the plans say they should be in their neutral position, and that's where I have them. And you can see down in here, I've got the rudder pedal tray just one notch here back from the full stop, which is here. And so again, there were a lot of surprises here regarding that. But anyway, this is where I'm at now. This is a quick picture here of all the controls. I've got all the aileron controls, the elevator controls. The stick is all in. Everything is working perfectly. So again, there'll be other videos detailing all of that out. But The only other thing I'll comment on is the only thing I wasn't able to finish is the flap lever, because there is a plate that's supposed to mount on here that are supposed to have the indentations for the flaps. You can't actually make that plate until you get these control rods done and you have the wings actually installed with the flaperons on the airplane, and you adjust it kind of as the last thing, because you're measuring the flaperons for the correct number of degrees and then creating the notches or marking the notches based on where the handle falls within that that adjustment and notch plate that we have to make to actually create the indents for the flap position. So again, that's something that I'm gonna have to do at the very end, but yeah, everything else here is looking really good. And again, these were the potentiometer based throttle controls that I created with the knobs on them, and then I've got the ignition switches here, which are used to start the turbines. So anyway, we're going to go over that in detail also. This is the plate. I'm just going to show you this real quick. So I made this plate because there's supposed to be levers here that mount for the mechanical connections to cables, and what I did is I mounted my my digital throttle controls in here, and then this plate actually mounts up underneath here and is held in place with just 2 screws, one on each side, so I can drop this down and get into all the connections, which are all snap connections that have positive locking type connectors on them. So that seems like it's going to work well. But part of the reason I got into trying to figure out all of this stuff with the throttle controls is that I got to run a lot of wiring up and down underneath the forward fuselage here, and I wanted to figure all that out before I installed the skin. Now, I thought I was going to be able to run like a tube across here or something, have some kind of tube that was inside of here, but now I'm worried about catching my feet on it. Again, I was not expecting there to be my toes to be this close to the top fuselage skin, so it actually makes more sense now to run wiring along the outside of the fuselage, possibly from the back side of here where the instrument panel is going to be, to the front along the inside of the fuselage here, where your feet are never going to be inside of here. But your feet are going to be inside of here. The other option is to possibly run something down through the center here, as long as you can get around the upper mount for the nose gear. But again, you can see I actually did the mounts already for the instrument panel, which I have installed already once I had the forward skin in here still clecoed. This is kind of the mock-up that I did here of what the instrument panel is supposed to look like, and then this actually worked really well, by the way. So I used this corrugated signboard that you can get at like Lowe's, or even I think you can get it at possibly Walmart, but it's got holes in it in one direction. So I cut this so that I could still make the pins that are supposed to hold the instrument panel in and in like that. But what I did is I had scrap pieces of this, so what I did is just put one end of it into the pin, and the other end I was able to actually fit into the the end here, so I could really install the like this. So what I could do is actually install the instrument panel, swing it back and forth up and down with the forward skin and the forward cowling installed for the instrument panel, and that was how I fit that in. And what this did is it made it so that I can now make a aluminum version of that, but I'm holding off on that until I actually figure out all of the positions for all the instruments. And then you start thinking about wiring, and how am I going to get wiring through here? Where am I going to mount the ECUs that I have? Where am I going to mount the fuel pumps that I have? Where am I going to mount a battery? Because what I've decided to do is use a single battery to control and power the Arduino throttle controls that I have, power the ECU for the turbines, and power the starters for the turbines, and also power the instruments that I'm going to have. Again, which is going to be an EFIS type system. So what I've got to do is figure out a battery mount out here, and that's going to be the next thing I'm going to try and figure out. I've got some ideas, but again, what I do for battery mount and what I do for battery is going to be based on how much ballast I need to get this airplane CG correct, which is going to be off because of the lightweight turbines that I have. So lots of things to think about, lots of things I'm working on, and anyway, it's coming along pretty well. So what I'm going to do next is we're going to go into this video and we're going to go over the installation and fabrication of the rudder pedal tray. We'll go over some of the things and changes that I made, which you may have seen, like these release mechanisms that I put in here. But yeah, thanks for watching the video. Please like the video. Please subscribe to the channel if you aren't already a subscriber. For those of you that are, I really appreciate it. It's really helping me out. So stick around. We'll get into setting up the rudder pedals. What I wanted to start working on today was the pedal tray. So I went ahead and cut out the shape of the pedal tray, and this is the one thing I was a little bit disappointed in the drawings. So many things of the CriCri drawings is so accurate that you can just cut the parts out and they just fit. This was one situation where there really was no drawing for the pedal tray. There was a picture of it and there were some dimensions of it, but there was no flat plate drawing of how this needed to be made. I did actually get a CAD drawing from Shannon. It just saved me some time. I could have done it myself. I just didn't want to deal with having to try, do trial and error, cut it out, bend it, see if things fit right. It was nice to just get a drawing that was already set up, that I know if I just bend this correctly, it's gonna be correct. So, so thank you, Shannon, for sharing your CAD drawing with me. So I went ahead and cut this out. And then what I did is I just cut out two square forms that are to the shape of what the inside shape of the pedal tray should be. Now what I'm going to do is take the inside one here and I'm going to round all of the edges that need to be rounded so that when I set it in here and bend it, I can make sure that I don't crack this, this pedal tray that I've cut out. Now what I'm going to do is I'm bending this all using a form, partly because there's tabs that are sticking out here which would be difficult to put in the bending brake and bend, but my bending brake tends to, at least with 40 thousandths, just bend things a little bit too sharp. I have a hard time controlling the radius, and it does tend to crack. So I think it's best, in my case, to actually create a form, just clamp it in the center here, and we'll just bend it up with a rubber mallet like we've done with the seat pan, for example. Now if you watch my seat pan video, you might have seen that I screwed up the first one. I think I mentioned I tried to bend the lip on it and it didn't bend correctly, it cracked. I actually cut this out of the leftover scrap that I had from that seat pan. So again, that's one of the ways I was able to reuse some of the materials if I screwed them up. So that's where this came from. So let me go ahead and round the edges on this form. Let me get it clamped into here and we'll see if we can bend up the sides of the pedal tray. Okay, I've got the form clamped in here, and you can see I rounded the lower edges here on the three sides, and then you can see what I did to the back part of the form to round that edge. So I'm ready to pound on it with a hammer. We'll see what it looks like when I'm done. So this turned out pretty good. I mean, for something I pounded on with a hammer. I've got the sides bent. Now I didn't bend these tabs across the back, mainly because if I try and just bend these over, it's going to want to bend across this hole here. So what I'm going to do is take it out of the form and maybe put a clamp or something across this so I can bend this over and still keep this straight 90 degrees. Otherwise, like I said, it's going to bend across this hole. But otherwise, it looks pretty good. It just needs some additional pounding with a hammer. I did bend these tabs over. They just got to be cleaned up, but the holes are pretty close to lining up. And yeah, everything just needs to be straightened up and cleaned up a little bit more. Well, let me see if I can get these tabs bent and get the form taken out of here. I did have to cut a little bit more off this form across the back here because I wasn't able to get this to bend around the way I wanted it to. So I did adjust that, and then I also went around to all three sides at the same time and put a few degree bevel on here to get it so that when I pounded these down with the rubber mallet that it would actually go up to 90 degrees. Otherwise they were bent out a few degrees. But yeah, let me see if I can get these tabs bent and show you what it looks like when I get the form out of here. Well, it's still not perfect, but it's pretty close. I'm actually very happy with the fact that I was able to get the four corners drilled and connected together. The holes lined up pretty well. So yeah, I mean, I guess it's good enough for your feet to sit on, right?
So I'm gonna keep cleaning this up a little bit more. I'm gonna go ahead and Scotch-Brite some of the outside of this. I'll probably just Aladine this just to protect it. Also, to bend these corners, what I did is I just got a couple pieces of aluminum like so, and I rounded one edge. Let's see, I rounded this edge here on this side, rounded this edge on this side, and I just stuck them in here like so and clamped a piece of metal on either side of it. So one on the outside, one on the inside with the radius here, and then I just put a clamp across it and just bent these corners over. That seemed to work pretty well. I don't know how else I would have done it. They definitely needed to be bent carefully so that it didn't crack, and of course, like I said, trying to not have this bend here at the corner work its way over into the hole here was my biggest concern. But this worked okay. I mean, it is what it is. I'm going to keep working on it, and I'll show you what it looks like when I get a little bit further here.
Now that I have the pedal rail tray formed, the next thing I want to try and do is make the attachment brackets that are supposed to mount to the bottom of this that allow this to be secured to the pedal rail. Now, the manual indicates that you can make these out of phenolic. It's called Celeron is what they refer to it in the plans, but it's really phenolic. Or you can make it out of aluminum. Now, if you make it out of phenolic, they're supposed to be 5 millimeters thick. If you make it out of aluminum, you can make them as thin as 3 millimeters. And what these do is there's pre-drilled holes inside of this pedal tray, and these are going to attach to the bottom, and you're just supposed to put screws through here and then screw through whatever material you make it out of, whether it's the phenolic material or aluminum. But I've got a ton of this scrap 1/8 inch material that's left over from doing some of the wing spars I did originally. And so what I thought I would do is I'm going to make mine out of aluminum and just start using up some of this stuff. I can set this up in the CNC machine, and I can actually just cut them in a row down this strip and see if those will work. So I'm going to go ahead and see if I can cut a couple of these out, see what they look like, see if they're actually going to work, and see if I can get the holes drilled and actually get a set attached to this pedal tray, and maybe secure some of these with some clecos and see if I can secure the tray to the pedal rail and see if I can get this set up so it works. It's a little bit the manual doesn't really tell you exactly how to make a lot of this stuff related to the rudder pedals. This tray, there's a picture of it, but there's no actual drawing. There's a few dimensions, but no detailed CAD drawing or detailed drawing I can turn into a CAD drawing. And it's the same kind of thing for these brackets that go on there. Yes, there's a few dimensions on there, but nothing's really exact. It's kind of, well, you're kind of just left to figure it out, and it's kind of what I'm doing here right now. And so the thickness that I'm concerned about is, since this has to attach underneath the pedal rail, it's kind of a guess on my part as to how much material I need to take off of here to leave enough room for the pedal tray, or I'm sorry, for the pedal rails, because the pedal rail's curved a little bit. It's got to attach and be, it's got to be secure enough that it's not wiggling around, but it can't be tight enough that it doesn't slide. So I'm going to be playing around with this a little bit. Let me cut some of these out, and I'll show you what they look like when they're done. This is the first retainer, pedal rail retainer, is that what this is called? But this is the first one I was able to cut on the CNC machine. This actually looks really, really good. And so if we look under here, what this is supposed to do is hook underneath the pedal rail like this, and then it's supposed to bolt to the bottom of the pedal tray, and the pedal tray is supposed to then be able to slide up and down without coming off. And then you're supposed to be able to take one bolt out, loosen this, and tilt it to the side and be able to pull the pedal tray off the pedal rail without actually removing these completely. But I think this is going to work, so what I'm going to do is just make a few more of these. I think until I actually mount these onto the pedal tray, I won't really know if I've got the depth there correct, if it binds or not. If it's loose, what I can do is just take a little bit more material off the top here with my mill. If it's a little bit tight, I can just take my mill inside this edge here and just take a little bit more off. But yeah, this looks great. I'm going to keep going with this. Here's the 6 pedal tray retainers that I cut out. They look great, so what I'm going to do now is just go ahead and drill out the holes that are in these and the pedal tray that are already matched up. I'm going to drill them out to 3/32 and get some clecos in them and see if I can attach it to that pedal rail down there.
So bear with me on this next clip. It was accidentally recorded in time-lapse mode, so I'm just going to talk over the video here. But I was able to get all of the pedal rail retainers installed on the pedal tray with Clicos, and it seems to fit actually quite well. The only issue I found is that once I had it installed, that the rivet heads on top of the pedal rail were actually rubbing on the bottom side of the pedal tray, and it's not moving freely. So I'm going to have to actually knock down the tops of these rivets so that it slides back and forth properly.
I'm kind of glad I didn't finish attaching the top of frame 2 and the center support, because I was able to just take the Clicos out and remove it so I can get complete access to this pedal rail area. I did put tape on top of here just to try and locate the high spots, because you can see every place in the tape where there's a high spot, it leaves a bump. So some of these I did a good job on, but other ones like these up here, this one's really high. I'm going to go ahead and take a Dremel tool and just go over the top with the tape on it. I'm just going to wear the tape off and just knock down the top of these rivets. And I think I can get them pretty smooth. I can even run over it with sandpaper with the tape on there, and I think I can level it all out. So let me play around with this a little bit more, and I'll get back to you in a minute. Well, I made some good progress on this. It's sliding nice now. There's a couple things that I did. Obviously, I knocked the tops off the rivets here, but then I also went ahead and took the tape back off once I ground each one of them down, and just took some sandpaper and Scotch-Brite and just cleaned up these rails just to get them nice and smooth. I wasn't worried about the Aladyne at this point, because this is going to be sliding on top of it, scratching it up anyway. But the other thing that I found that was actually a little bit of a bigger problem was that the lip that's on the inside of here seemed to be rubbing on the hat section that's underneath this top layer on the pedal rail. So, for example, if I take this off and just move one of these out, so this little tab that goes underneath the rail was actually rubbing, it appeared to be anyway, rubbing on the hat section underneath. So I didn't have quite as much clearance underneath this cap as I had cut into this into this guide here, or this retainer here. So what I did is I took each one of these off and just set them upright on my mill and just ran across the top and just cut a little bit off of each one, the same amount, and that seemed to have fixed most of the issues. So it slides pretty freely now. It's it's not perfect, but it's also not lubricated or anything else, and it's only going to loosen up more over time. So yeah, very happy with this at this point. Now that I have the pedal tray sliding back and forth pretty easily now, what I'm going to do next is go ahead and drill out all the holes here for the pedal rail guides that I made, and go ahead and tap the holes for all of these 12 holes here, I guess. The other thing I'm going to do too is I made and cut out these on the CNC machine. So these are the supports that go actually pop rivet to the side of here. Actually, I'm not sure if it's pop rivets, it's probably solid rivets, but these rivet to the side here, and these are what actually hold the rudder pedals that bolt through these holes. So I'm going to go ahead and get these cleaned up a little bit more, Aladyne them, and spot stamp these bearings in. I got a few steps further here on the pedal tray. I overcooked this a little bit with the Aladyne. I got some new Aladyne and forgot how much stronger it is when it's fresh and new. But anyway, so I drilled out the 4 corners of the pedal tray and installed the pop rivets that need to go on the corners. And then, as you can see, I spot stamped the bearing in place on these support brackets that we have for the pedals themselves. And those get installed with solid rivets, as I suspected. Now, we didn't talk much about the rudder pedals themselves. I actually didn't make these. John at Northern Machining made these for me, and so I'm not going to go through the process of actually welding these together because I didn't do it. But very grateful for John for doing this for me, because it saved me a ton of time. So what I'm going to do next is these actually get installed and, let's see, bolted on the side of the pedal tray like this into those bearings that we created. This tube is actually going to go in between these and slips into the bottom
of the pedals themselves and just holds them together and allows them to articulate separately, just sliding on a greased tube that's in the center. Now I did test fit this together, and I'm going to put it back together just to show you. I was a little surprised at how this works and how these articulate back and forth, that it actually causes that tube in the center to go like this, because of course the the point of rotation of the bolt holes down here, the point of rotation of that tube is up higher. So if you push one pedal forward, this is rotating forward at this radius, and if you take this pedal here and move it backwards, it moves the other direction. So you end up with this offsetting articulation of the pedals, which I wasn't expecting. I was, these are bolted together, they're connected with the tube. I was thinking they were going like this and that it was just a forward and backward movement, but it was a little strange when I saw it at first. I thought, well, that's kind of weird. And the other issue, which I'll show you in a minute when I put it together, is that you can actually start having some binding here. I know there's a circular bearing here that rotates, which allows it to get some movement to the side, from side to side, but you can also start hitting the base of this attachment point on the side of the fitting here that's holding the bearing. Now I'm assuming that the travel within the rudder is not far enough that ever happens, and I'm sure with adjusting the cables to get the position of the pedals correct, that won't happen. But again, this was all a little bit strange on how it actually works. I was a little surprised that the designer did this way, but obviously it functions correctly. So let me put it together and I'll show you in a second. So here's the pedals installed, and just with temporary hardware through the bearing holes down there. But you'll see what happens here is I move one pedal forward, and of course this is always what would happen if you're moving your rudder pedals. One moves backwards as one moves forward, and they're connected to one another. So you can see what's happening here is this rotates. I'm just moving one side, of course, because I don't have anything connected, but you can see it's twisting the tube in the middle, so it's no longer aligned in its center like it is here, and kind of rotating on this bearing in the bottom. The assumption was that they both move together, is what you're thinking when you're putting this together. It'd move like this, but it actually doesn't, because obviously they're connected together with cables inside the airplane. Now it seems like it's going to work just fine. I mean, with the bearings that we have in here that are designed to rotate, the spherical bearings, it's fine. It's just something that I didn't expect to actually function that way. But what we'll do is we'll put this all together in the airplane with the cables on it. We'll check the throw on how far these actually move, and then we'll just double check and make sure that we don't have any binding with this metal assembly actually hitting the bracket or anything in here. The other thing I will notice, or will point out here though, is this is really a good place where you need to use the jet nuts, which are the really small aircraft lock nuts. These hardware store, cheap hardware, have huge nuts and are really hitting the inside of the aluminum frame of the pan there. So again, I'll keep working on this, and we'll see if we can get this actually in the airplane and start hooking up some cables. I do have some finishing stuff that I need to do on these pedals, such as adjusting these tubes at the top, which are supposed to be kind of cut down so that the cable can actually flex as this is going forward and backwards in the assembly. I want to get these painted also. But anyway, it's coming together really good. It's a fairly simple process. It's just a lot of little steps. So I'm going to keep working on this, and I'll show you what it looks like once I get it back in the airplane. Well, I'm attempting now to try and make these cable guides for the rudder pedals that attach to the side of the fuselage. That basically the cable goes through some Teflon tubing that needs to be wrapped around something that looks like this. It's just like a cable strap. Now you can buy these on like Amazon. The problem with buying them on Amazon is that they're a little bit bigger. They're all steel, and they have a much bigger hole than a standard rivet size. I think most of the ones I found were 4mm hole for like a screw or something like that. And since these are going to be pop riveted onto the side of the fuselage, I thought, well, maybe I'll just see if I can make some. And these are only supposed to be made out of 20,000, so this stuff is really easy to bend. What I ended up doing is I found a scrap piece of cutoff from, I think it was cutting out the motor mounts, I'm not really sure. But what I did is I just took a 1/4 inch drill bit, a 1/4 inch mill, and just milled a slot into here. 1/4 inch is a little bit bigger than a 6mm. It's about 6.4 millimeters. And then I kind of went around either side of it with the mill just to kind of widen it out a little bit. And then what I attempted to do was just put one of these pieces up to here
and then I ended up using a 6mm reaming shaft tool. So it's a reamer on one end, but I'm just using the shank on the other side to put in here, and then I put it in the vise and I just clamped it. It seemed to work okay. The only problem is it wasn't perfectly straight. So this first one ended up, I don't know if you can see it in the video here or not, but it's the angle's off just a little bit. So if I put it on here, it's not 90 degrees, not parallel. It's really close, but this was kind of a test one anyway because this hole got messed up on the one end. So what I'm going to try and do though is I'm going to see if I can bend some more of these. You know, even if I have a 50-50 shot at getting them right, it's fine. I can just cut more of these out on the CNC machine in a matter of minutes. So I'm going to see if I can clamp and bend some more of these and see if I can get some that look fairly decent that we can use to start installing the rudder cables. I think I found a method of getting this to work. Don't mind my mess on my table here. So what I did is I measured and just put a small mark right in the center of this. Then what I'm doing is I'm squaring it up on the edge of this just scrap piece of metal that I have. It has a little bit of a radius on it here. And I'm just putting a slight bend in this. I shouldn't say a slight bend. I'm bending it enough, you know, probably, I don't know, 20 degrees or so down the center here, just so I get a nice mark in the center and I get a good straight bend. That seems to be the trick to starting this off. Then when I walk over and put it in the vise, which I'll show you in a minute, I'm able to bend it and they seem to be coming out straight enough, as straight as they need to be anyway. So let me go show you the next step after this. This is how far I bent it over there in the other room. So now what I'm going to do is stick this in the vise. It's going to be kind of spring loaded a little bit, and it's going to help hold my little form into place. And then after I get that set up something like this in here, we'll be able to slip the 6mm shaft into here, and then we'll be able to clamp down on it. I'll show you that in a minute too. Okay, so here's what it looks like after I slipped it in the vise. The spring tension on this is just holding all of this together, but I've got enough of a gap there now that I can slide this shaft in here. So what I'm going to do with one hand is hold this, and with the other hand clamp down on the vise, and I'm trying to make sure that this stays flat and that the piece in there stays as flat as possible. And I can actually, you know, move this right or left to make sure that this all stays square. But that's basically what I'm doing, is putting this in here like this, clamping it down, and it comes out really good. So I'll show you what it looks like when I get it clamped here. Okay, I have one of them clamped in there. So what I found out though is that because I didn't make this the perfect shape, I didn't radius those edges perfectly, I just kind of rough radiused them. What I found out that works well is if I actually take this out of here and flip that little bracket over and clamp it one more time. It seems to square everything up and make everything look a little bit more uniform than just doing it one direction, because like I said, I think it's the inside radius corners here that are not perfect. So what happens is on one side it looks like it's turned, but it's actually not as far as the hole goes. It just looks like that because of the way the light reflects off the corners. So I'm gonna pop this out, turn it around, put it back in there, and just clamp it one more time to clean it up. Well, I have 3 of them done now, so what I'm going to do is just go finish up the rest of these and get them finished. And I will go ahead and clean these up a little bit. I'll probably even iodine them and get them ready to install in the fuselage. Well, there's my completed pile of cable straps. I did end up I was able to salvage all of them except one. So I did make one new one, but instead of going upstairs and trying to redo all the cam for one part, I actually made one of these by hand. I won't tell you which one. So we're going to go and figure out where these need to go on the fuselage. It looks like they're 18mm down from the center line of the fuselage. That might be a little difficult to figure out, but we're going to go figure out in the fuselage where these need to go, see if we can drill some holes and cleco these in to where they need to be. I've had to go back and dig through several different drawings to try and figure out where to start installing these cable supports. And what they do is they run basically along the side of the fuselage here around the seat area. And what I found is that on one of the fuselage drawings for frame 4, when we drilled these holes in here for these rivets, you'll see the spacing over here is different than over here because one of these is supposed to go on the back side of frame 4. And it's supposed to be 1, 2, the 3rd and 4th rivets up. And what I had always planned on was drilling these out and then installing this in, you know, where it's supposed to be and pop riveting it in. There's supposed to be one of these on each side at the aft side of frame 4 because there's actually a cable stop that attaches to the cable right at frame 4 here that I believe there's about a 50mm spacing, but it has rubber washers on the front of it and a clamp that goes on
the cable here, and that's the stop for the rudder system, which I didn't know exactly where the stop was for the rudders, rudder pedal travel, is actually located right here. So what will happen is the cable will move up and the stop will actually hit frame 4 and this cable support here and provide a positive stop on this side and on the right side of the fuselage. So there's one on both sides for each one of the pedal travels back and forth. So what I'm going to do, I think, is start with installing these first, or at least, I'm going to drill these rivets out. I'm going to go ahead and Cleco these in, get these holes drilled in here. I got to make sure that these holes match the same spacing I have on here. I believe it's 18 millimeters. The spacing on these holes after I bent them is actually about 21 millimeters, so I'm going to have to kind of move these holes over, but these are just 16th inch alignment holes, so I'll be able to move those quite easily. And I've got plenty of space. So I'm going to go ahead and drill those out and see if I can Cleco these in, and I'll start figuring out the position on each one of these other frames, which I believe is at the same horizontal location as far as its position within the airplane, but of course you can't measure down from the top and bottom because the fuselage is curved. So I'm not sure exactly how I'm going to figure out where that exact spot is on each one of these frames. Again, it's probably not critical because, again, the cables go back here and there's cable support that goes across the back. The alignment of that, it doesn't have to be exact, but we'll try and get as close as we can. So let me go ahead and drill these holes out, and we'll go and figure out where the rest of these go. So I Clecoed in the frame 4 guides for the rudder pedal cables. Those seem to line up just fine. I tried to go back to the drawing though and figure out where on frame 3, 5, 6, and 7 that these guides are supposed to be installed. Now, there isn't any other markings on any of the other frames except for frame 4 where these go, and the only other reference I have is that it's supposed to be centered 18 millimeters down from the center of the fuselage, or the datum line of the fuselage. So what I think I'm going to do is, you can see I stuck this 3/16 rod in here, just ran it through the hole that I have right now so that I can try and at least make sure that I'm correct and have a straight line across to each one of these cable supports. It does look like this rivet here, which is 1, 2, 3, 4, 5, the 5th rivet down ends up being the top rivet for this cable support on frame 5. 6 and 7, I don't really have a reference, but there's no rivets in there anyway, so I can kind of drill them where I want. And I think what I'm going to do is on frame 7 here, I should be able to measure into the, from the middle of the top of frame 7 to the bottom of frame 7 into the middle and measure down 18 and put a little mark. And then I can use this rod to figure out exactly where that one needs to go. I can attach that one and then kind of fit the one for frame 6, just to make sure it's following the same path. I think I'm going to do that, and then when I get up here, it's possible, from what I can tell, that this rivet on the bottom side here, so 1, 2, 3, 4, 5, 6, is actually the bottom rivet for this strap that goes here. At least it's lining up that way. But I got to do a little bit more measurements to see if there's anything on frame 2 or possibly frame 3 to go off of. I did some more measurements here, and I just taped the back of this rod onto frame 7 at that 18 millimeters below the center of frame 7, which should be the datum line, 18 millimeters then below the datum line. So what I did is I took one of these clips and I just kind of aligned it here and pressed it up against here, and from what I can tell, I'm just going to take out the bottom rivet here, or this lower rivet that's just below the rod. That's going to be the bottom hole for this attachment at frame 3. And then if I go back here, the attachment of this at frame 5 looks like this rivet here is the upper hole. So 1, 2, 3, 4, 5 is the upper hole, and 1, 2, 3, 4, 5 here on frame 3 is going to be the lower hole. That seems to keep this rod level with the stiffeners that are in here, which should be at the datum line, as far as its distance below, equal to what it is on frame 4, and then it comes out good there at frame 7. So that's what I'm going to do. Again, this is a cable. It doesn't have to be absolutely perfect, but obviously we don't want any binding. We don't want any up and down motion of that cable that's going to cause these Teflon pieces that we put inside of here to wear faster. So
Just trying to get it as good as I can. I'll just duplicate what I did here on the other side and just put it in the exact same spot. I think we'll be good. So I'm gonna keep working on these and go ahead and get the holes drilled for these and get these CliCo'd in so we can start test fitting the cables. I knocked these rivets out, drilled the heads off, knocked them out of these 4 spots here that we're going to attach these clips to. I thought I'd just comment though, it would be a good idea to try and find those rivet tails. In other words, we knock the rivet head off. I've got the rivet head, but then you end up using a punch to punch out the tail of the rivet, which falls down into the frame. But the bottoms of these frames are slightly open. In other words, there's open corners down there at the bottom where the angles are. Now I think what I'm going to do is I'm going to try and find these rivet tails, because if I don't find them now, they're likely to come out when I'm flying, and they're going to be floating around the canopy if I go upside down. And so I think I'm going to try and find those so that they aren't floating around someday when I'm flying, because that's when they will come out and end up being a bother. So I'm going to see if I can locate those, see if I can shake them out of there, or see if I can figure out exactly where they are. But I just thought I'd comment on that, because it's something that you don't really think about that might be a problem later. I just cut out these tiny little straps that are used on the rudder connection for the cables to the rudder horn in the back. So these are basically like a turnbuckle or a shackle, I guess you'd call it, that has to be bent. So we're going to fold this in half, and we're going to bolt it through these 2 holes to the bearing that's on either side of the lower rudder bell crank. And we do have to shape these a little bit, because they have to go around the cable turnbuckle that gets installed on the end of it. And we'll go through that and I'll show it to you. But I did want to show you these pieces and how well they came out. And I'm absolutely thrilled, because this was really making me nervous about, again, having to come back and cut some more steel parts, because I thought I was done with it. So we're going to start working on bending these, and I'll show you what they look like when we get one done. I just received in the mail the Teflon tubing that I'm going to put in each one of these cable supports that we're going to pop rivet on here. I didn't want to pop rivet those in until I got the tubing, because the tubing kind of needs to be clamped in there with the with the bracket. So I'm going to go ahead and pop rivet those on with the tubing in it. But I just got this off of Amazon. This was like, I think, $7, and this stuff is apparently used for 3D printers. This is like the guide tube for the plastic line that you're using for 3D printing. And this is 4mm internal diameter and 6mm external diameter, which is what's exactly recommended in the plans. So I'm going to go and cut some little pieces of that, and we'll start to pop rivet these cable supports to the side of the fuselage. What I'm planning on trying to start working on today is the rudder pedal cables, and there's a lot to talk about here, because there's a lot of parts and things that we have to do to get these cables installed. So let's just go over the cabling first. So in the main part of the rudder system uses 3/32 cabling. Now you probably could go to 1/8" cabling, but 3/32 is all that's required per the plans at 2.4mm, I believe it is. So what I've done is I purchased 30 feet of this is what 7x19 stainless steel cable. This stuff is super flexible, which is really nice. So 30 feet of this, I got it from Aircraft Spruce. And in addition to that, we have to have some 1/8" cable that is used to connect to the steering bar in the front to the nose gear. So what I ended up doing here is I bought 3-foot long, actually I special ordered the cables for the front that connect to the steering arm, because you can actually have Aircraft Spruce swage these ball ends on here for you, and basically order custom cabling so that you don't have to buy a swaging tool. Obviously these balls, I just needed 2 of them on the end. Nothing needs to be on the other end, because it gets clamped to this cable somewhere around frame 3. And so I went ahead and just ordered these with the ends already swaged on there. I didn't have a tool that would do that, and it didn't make sense for me to buy one just to put 2 ends on cables. It was much cheaper to just order the cables, special order, with those ends on it, and they look perfect. So I think that's going to work out great. Now, I obviously couldn't order the rest of the cabling with ends already on it, because it has to be installed and the ends have to be wrapped around existing connections within the airplane.
for example, well, this is a good example right here. Obviously, we've got to wrap a cable around here and crimp it on the ends in order to connect it to this steering bar, which goes behind the seat in the airplane. So I'm going to start out by commenting on a few things here with the hardware too. So I ordered these pulleys that are what actually are connected to the front steering bar cable. So this cable attaches to this cable around frame 3. It wraps around a pulley and goes to the rudder pedals. Now, I ended up with an issue here because I thought these were going to come with bushings. I'm sorry, I thought these were going to come with bearings, but they actually came with bushings, which isn't really a problem other than the fact I would have preferred to have a bearing in these pulleys. But the bearing pulleys were way more expensive, and in addition to that, I couldn't find the correct like 2-inch size that was for a 16th inch cable. And so I ended up going with these. They came with a bushing, but what I'm going to do is I've got a number 10 screw that I'm going to put and use what I've used in the past as a shimming material, which is this is a 1/4 inch 4130 rod. It's the same rod that I was using for the wing pin handles and also the bushing for the upper part of the nose gear assembly, where we also have a number 10 bolt. So I'm just going to use this, and it fits perfectly inside at a 1/4 inch. I mean, there's no play almost at all. So it's a good fit for a bushing for these 1/4 inch pulley assemblies. So I'm going to use that. You do have to remount this inside of this tube just a tiny bit to get a number 10 screw in, but it's just a small amount. And so I'm going to use number 10 screws on that with a bushing on top of it made out of this 4130. So I basically have all the materials now. Now John from Northern Machining was able to make these clamps for me that attach the cables to this tube that goes in the center of the airplane. So what happens is the rudder horn actually connects to cables on this part in the center of this tube that is positioned behind frame 7, behind the seat, and then from there there's cables here that go up along the fuselage into those guides that we installed, all the way along the inside of the fuselage, all the way up to the rudder pedals. So this tube is all ready to go. And we've got the clamps that we're going to use that John machined on his equipment in his machine shop. These are something that we're going to have available on the website, so you can just buy these if you want. And let's talk about the thimbles. So I've got some hardware here to attach this stuff. These are the thimbles. The thimbles from Aircraft Spruce, the 3/32 and the 1/8 inch thimbles are the same size, so you can use the same part for both 1/8 inch cable and 3/32 cable. I do have my sleeves here that I'm going to use for the 3/32 cable, and I did buy a swaging tool. Now, I couldn't afford to buy a Nico press, which is obviously the standard in swaging tools. I think they're like $800, but since I only have, I think there's like 6 connections that we have to do with these cables, I went ahead and picked this up from Aircraft Spruce, and this is a hand swaging tool that does up to 3/32, and so I think this will be fine for everything that we need for the CriCri. I don't do any other aircraft cabling other than what I'm doing here, so I wanted to go as cheap as possible, and I think I paid about $140 for this tool, which is probably worth it. But like I said, since you can get these ball ends crimped at Aircraft Spruce, that's the best way to go, is just order those cables with the connections already made. So I've got everything ready to go here. I think what I'm going to start off with is these parts here that I cut out on the CNC machine, which are made out of 4130 steel. These need to be bent so that we can actually fit, let's see, we're actually going to fit one of these over the top of it. So this has to fit inside of here, which is going to be an interesting task, but this fits inside of here and gets bent around to hold the cable in, but then this also has to be shaped to the curvature radius of the inside of this. So I'm not exactly sure how I'm going to bend this. I might have to heat it up, I believe, to even bend it in half so I don't break it, and then to shape the inside of it to round it. That's what I'm probably going to play around with first, because I got to get that done, get the holes drilled out of here so that we can attach this to the bottom of the rudder. And then from there we can crimp the first cable that's going to wrap around these, and those are going to come all the way up to here, and we'll do another cable crimp here to attach this. And once this is done from here back to the rudder, we'll go ahead and swage the cables here on the ends and continue up to the rudder pedals. So that's what I'm going to work on now. I'll kind of show you as I'm going along here what I've got finished. I'll work on these first, like I said, and I'll come back and show you what it looks like when I get something that'll work. I screwed up on the first thing I did today. So I thought I would go ahead and drill these holes out in these shackle straps that we need to make for the rudder, and I had measured the bearing to make sure that I understood that this radius that needed to be bent in the center here, that this needs to be folded over to, is the width of the bearing, which is 6 millimeters. So I had 6 millimeters in my head, and so I drilled a 6 millimeter hole in the end of here where a 5 millimeter bolt is supposed to go. So I got to make another set of these, but what I'm going to do is use this one here and just do a test bend on this one and see what the best way is to get the 6 millimeter radius, 6 millimeter diameter bend in the center here, either in the vise or something. I did test bend a piece of this just to see. It's not going to crack or anything, so I don't even think I need to heat it up. It seems like it can just be cold formed, so I'm going to go ahead and see if I can take this one and radius it in the middle and see if I can, round it a little bit so that we can get it to fit nicely inside of this. So let me go ahead and play around with it a little bit more. I'll try not to screw up any more parts, but I'm going to have to go on my CNC machine now and cut out a couple more pieces of steel, which I really didn't want to do today. But yeah, let me see if I can test bend this. I'll show you what it looks like. Here's what I'm going to attempt to do. So this is a 1/4 inch reamer. I'm just going to use the shank of it, and it's clamped into a vise with aluminum chuck or aluminum jaws in here, so it's not, shouldn't do any permanent damage to my reamer at all. But what I'm going to do is just tap this. So I put this in there about where I think the midpoint would be after it's bent part way around, and I'm just going to try and tap this over and see if I can get this wrapped around, and then I'll kind of figure out a way to wrap it around the rest of the way. I think this doesn't have to be very precise, so we're just going to try and get as close as we can. It's more important that the holes line up, obviously, after we fold it in half. So let me go and pound on this, since I'm going to need 2 hands, one to hold the vise, and I'll show you what it looks like once I get it bent. Well, I didn't get very far with the shackles that we have to make for the rudder controls. This has been very frustrating, and I've been actually working at this for a couple hours now. So I bent 2 of these and got them, with a diameter of about 6 millimeters. I actually used a 1/4 inch, but close enough to 6 millimeters. I was trying to make it a little bit bigger. But bending it in half isn't too bad. The issue with bending it in half is issues like I ended up with here, which I wasn't trying to get it perfectly centered, but to get the holes on the ends and the ends of these lined up so that when you bend it, it actually folds into being bent exactly in the middle is difficult to do. The second one I did was a little bit off. It was okay, but I was able to kind of fix it a little bit by pounding on one side versus the other, and just manipulating it a little bit. But once you get it folded like this, it's very difficult to put it in anything, to grab it, to be able to clamp it, to do anything with it, to continue to fold it or do anything else with it. So you just have to be really careful when you're doing the initial bend that you try and do it in the middle as close as possible, and that as you're doing it, bend it a little bit more, see if you think one leg is going to be longer than the other, and then try and move your position where you have your pin a little bit over to one side, try and pound on one side versus the other to try and get it folded in half. So that was number 1, but that's actually the easy part. The difficult part is that we're supposed to take and put a radius in the end of this so that when this gets attached in here, let me see if I can put it in here like this, that the end of the shackle we're making is supposed to kind of be radius so that this will rotate inside of that shackle and not just rub on the edges, which we wouldn't want because we could end up wearing out this clevis fairly quickly. So the problem is that if I try and I thought I had a perfect way of doing this. What I did is I put this back in here like this, and I put this basically in my vise, and I clamped it about right there. And then my intention was to just heat up the end of this and then use like a larger punch, like this 5/16 punch, put it on the end of it, hit it with a hammer to try and radius the end of this. I ran into many problems with doing that. One is that once I put this in the vise acts like such a heat sink that I can't heat up the end of this enough to be able to make it pliable.
if I just hold this in my hand, like, not in my hand, but with a pair of pliers or something like this, or vice grips, and I heat it up, I can get this red hot. But I can't then put it in a vise to hold it, to pound on it, to get the end to radius. So I did try one other thing, and I used this method that I did here to actually hold this in there. And I used one of these vice grip clamps. Let me go find it, hold on. Anyway, so I clamped it in here and clamped this in there to hold it and support it. And then I heated it up, and I was able to heat it up red hot on the end. And then my plan was I'll just set it upright on top of my vise, and I'll just take this, you know, punch, set it on top, and hit it with a hammer before it cools off. That didn't really work either, because then what happened is this top radius part is the stiffest part of this material, and even though I'm only heating the top here, it ends up heating up the edges down a little bit into the straight part. So what happens is you start hitting on the top, it just starts bending and flattening the sides, and not actually pounding in the center here and radiusing the edge. It just starts flattening the edges out and flattens the whole top out. It doesn't radius anything. So it really just caused, it was just never-ending problem. So I've already ruined both of the ones I already cut out to try and do this, and I've spent a couple hours doing this. What I'm thinking of doing is, I know there's probably a way to do this. I'm just not a metal worker as far as heating, bending, and figuring out how to do this. I haven't figured out a good way to hold it without there being heat sinking issues, and I can't figure out exactly how I'm supposed to bend this and hold it at the same time and heat it. It's too small of a part. But what I did look at is Aircraft Spruce does make shackles. You know, there's aircraft shackles that you can buy that are designed for this size of thimble. And the only issue is they're a little bulky, they're a little bigger, they're obviously going to be a little bit heavier. But the good news is the shackle, which is the ANN 115-21, which is the one that's designed for this size thimble, it has a smaller bolt hole in it than the required 5mm that we need, and it's a little bit thinner in its spacing in the middle here, but of course it's much thicker on the edges as far as the thickness of the material that you know you're bolting through. And of course we don't need anything near 2,100 pounds of capability out of this shackle. So what I'm actually thinking of doing is just buying 2 of the aircraft shackles. I can drill the hole out to 5mm, and then what I can do is I can put it in my mill, and what I can do is just mill out the center here to the 6mm that I need. And believe it or not, based on the thickness of the materials, the thickness of the end of the shackle, that's the ANN part number, I can take out 35 thousandths on each side and still have, I think, 46 thousandths of material thickness, and of course this is only 40 thousandths. So even if I take that, mill it out down the middle, and drill it out, I can make it fit. And from what I can tell, the distance between here and where this thimble needs to go is about the same. I think it's 9/16 of an inch from the center hole to the center of this radius here. I need to measure that a little bit more accurate, but I know that the rudder horn is 22mm wide, so it's only 11mm from the center to the edge, and I know that falls short of this hole to the center of the where the thimble mounts. So I believe it will actually fit, and I can actually then use the aircraft ones that will be a little bit easier to just mill and make fit than it is to try and bend this to make it fit. Somebody else can probably do this quite easily. I cannot. So I'm going to probably give up and just go ahead and buy the aircraft ones and work from there. So I'm gonna go ahead and order those, and I'll show you what they look like when they come in, and then we'll see what we need to do to modify them to make them fit on the CriCri, but I think they're going to work. So that's what I'm going to do. You didn't think I was going to give up, did you? All right, I was able to figure this out. This actually worked really well. So this is the end result on the test one. You can see the curve that I created in there, and it's supposed to kind of make the end of it somewhat square a little bit again. It's just going to flatten out a little, but at least I've still got the 6mm width.
And now when we put this on here, you can see it's got a curvature very close to the thimble curvature, which is really what we want. We just want it to slide back and forth without rubbing, scraping on the edge of, you know, steel on steel and wearing it out. So here's what I ended up doing. I ended up cold forming it, and I ended up cold forming it over aluminum, believe it or not. So I took a scrap piece of aluminum and I milled it down to 6 millimeters thick. I stuck it in my disc sander and just rounded the edge so that this would fit over the top of here, like this. And then what I did is I went back to the mill and I put a notch into it of the curvature that I wanted to create on the inside of this piece of steel. And then what I did is I just put the, it was actually kind of thick, hold on. Anyway, you get the idea. I slid this over the top of this, and then I clamped this as hard as I could in a vise. And then I took my 5/16, this is actually 1/4 inch, but I took my 5/16 punch, set it over the top, and just hit it with a hammer multiple times, basically as hard as I could. And I did have to reposition this, take this out of the vise, put it back in, because I'd actually pound this down in the vise. Now, surprisingly enough, I thought this was going to be a one-time use as far as each slot that I made, but the slot actually held up pretty well. I think I could even pound the curvature on a couple more of these. So what I'm going to do now is, now that I do have this figured out, it's not worth wasting the money or taking the time to wait until those other clevises came in. So I think what I'm going to do is go ahead and go on the CNC machine. I'm going to cut 2 more of these out. I'm going to see if I can bend them in half first properly, and then we should be able to use this little form to try and form and shape the, got one hand, form and shape this curvature that needs to be in there like that, which is pretty darn good considering what I thought I was going to have to do. So that actually ended up much easier. I'll see if I can bend them a little easier too now. I might actually use this initially to try and clamp and bend the curvature over, and I think I can get more accurate with my positioning of, center on center. Obviously I wasn't attempting to be close on this one. I was just bending it to see how it would work. So let me go cut some more out on the CNC machine. We'll see if we can get 2 good ones. I thought I'd show you the trick that I'm using when I'm bending these shackles that go on the back for the rudder. If you end up with one side that's short and one side that's long, you can actually take the longer side and actually clamp it in on one side of the vise, but leave space in there by putting spacers on the other side for clamping, so that this side is basically free to move up and down, whereas this side is clamped to the side of this piece of aluminum here. And this has actually worked quite well for me to just shift the length of these, because this end ended up being really long, this ended up being short. And so you can see I'm just leaving it high a little bit, and then what I can do is just take my hammer and just start pounding it down, and I can pound that side down into there, and that will make that side longer and this side shorter. But that's what I'm trying to do, to just get the initial setup so that the holes are lined up and that they're the correct length on each side before I knock that center curve in there. Battery went dead. So this is the second one now that I have bent, that I'm ready to put the curve at the end of it. But again, this worked really, really well. I don't know how else I'd do it without having this as kind of a form, because being able to shape that around this worked really, really well. Here's the first one I did, and that one turned out really good. I finished the end of it here, so it's got the curve made into it, which seems to be what they want you to have done in the plans, and it works well with the thimble. It seems to slide really well. It's not to the exact curvature of the thimble, but it rides nicely on the edges, which is the point. I mean, we don't want sharp edges on this starting to cut into this every time it has to move back and forth. So I think this will work just fine. So let me finish up this one, and then I should have both of these complete, and we can start actually working on the cables. Well, I can't believe I was actually able to finish these. It was a costly day, though. Obviously I had to make 2 sets of these, because the first set I didn't figure out how to bend right. I tried to cut the second set here, and I ended up breaking one of my router bits on my CNC machine. It was an older one that I was a little bit concerned about cutting the steel with, but then I got this bright idea of not wanting to damage my new router bit, brand new one that I had,
and I decided to slow down the feed rate a little bit just to make sure that it cut a little bit slower, but of course then it generated so much more heat that I ended up completely dulling the brand new bit that I got. So I killed 2 router bits today trying to do this, and was able to get this done though. It's almost 2 o'clock. I started at about 6:30 this morning, and today is 4th of July. So today's been a fun day. But I'm glad I do have these finished. Now I'm probably going to clean these up and maybe shoot a little bit of primer and paint on the outside of these. I'm not going to be too concerned about the inside of these. They're going to be rubbing on these thimbles, and they're also going to be on the greased bearings, so it's probably not a big deal, but I don't want too much surface rust on the outside, so I might just give them a quick coat just to try and prevent rusting. But yeah, I'm going to take a break, and then I'm going to start seeing if I can swage some cables and see how that goes today.